In this video, we want to do some true-false questions about limits of functions. True-false questions can be tricky and are often some of the most difficult questions for the students. The first question is, if f of x is x squared minus 4 over x minus 2 and the function g of x is x plus 2, then we can say that the two functions f of x and g of x are equal to each other. We want to figure out this statement is true or false. Note that we can write the equation of the function f of x squared minus 4 over x minus 2 as x minus 2 times x plus 2 over x minus 2. Now if we cancel x minus 2 from the top and the bottom, we get x plus 2. And so it seems that the function f of x and the function g of x are equal to each other. But note that in general, two functions f and g are equal to each other if they have the same rule. They should have the same rule, and also they should have the same domain. Here in this statement, the rules are the same. The function f is x plus 2 and the function g is also x plus 2. But the problem here is in the domain of the function f and the domain of the function g. Domain of the function g is all real numbers, because g is a simple line or it is a polynomial, and so the domain is all real numbers. But the function f, before simplification, this function here, the domain of this function is all real numbers except the point 2, because 2 makes the denominator 0, and we know that any number that makes the denominator 0 is not in the domain. So the domain of the function f is all reals except 2, and so the domain of the function f and the domain of the function g is not the same, and so the two functions are not equal to each other. So it shows that this statement is false. Now look at this statement. Limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to the limit of x plus 2 as x approaches 2. We want to figure out this statement is true or false. Similar to the previous question, we can write x squared minus 4, this expression, as x minus 2 times x plus 2 over x minus 2. Now if we cancel x minus 2 from the top and the bottom, this limit equals to the limit of x plus 2 as x approaches 2. And so it shows that this limit is equal to this limit. And so this statement is completely true. The difference between this example and the previous example is that here, because it's a limit and x approaches 2, we know that when x approaches 2, x is close to 2, but x is not equal to. So we are not worried about 2. X is only close to the point 2. So cancelling x minus 2 from the top with the bottom doesn't make any problem. And so these two limits are equal to each other. And so the statement is completely true. The next statement is if limit of the function f of x as x approaches 3 is 10 and limit of the function g of x as x approaches 3 equals 0, then limit of f of x over g of x as x approaches 3 does not exist. So we want to figure out if limit of f is 10 and limit of g is 0, then limit of f over g exists or does not exist. Note that here limit of f over g as x approaches 3, numerator approaches a non-zero number. It approaches 10, which is a non-zero number. But the denominator approaches 0. And we know that when in a fraction, numerator approaches a non-zero number, denominator approaches 0, the limit does not exist. Because when numerator approaches a non-zero number, denominator approaches 0, the expression gets larger and larger, is a big number. So limit doesn't approach a specific number, and so limit does not exist. So this statement is true. The next statement is if limit of f of x as x approaches a is 0 and limit of g of x as x approaches a is also 0, then limit of f of x over g of x as x approaches a does not exist. We want to figure out this statement is true or false. This given limit is in the form of 0 over 0, because note that when x approaches a, limit of f of x is 0 and limit of g of x is also 0. So this given limit is in the form of 0 over 0, which is an indeterminate form. And these type of limits, depending to the function f and g, may exist or may does not exist. So we cannot say that these type of limits exist or does not exist. And so this statement is false, because it is possible that these limits exist. Let me show you this by two examples. One example that shows that limit may exist, and one example that the limit may does not exist. And it depends to the function f and the function g. For example, consider this limit. Limit x approaches 1 of x minus 1 squared over x minus 1. First of all, note that if we plug in 1 for x in numerator, we get 0. So limit of numerator, like here, is 0. And limit of the expression in denominator, if we plug in 1 for x, is also 0. So limit of the denominator is also 0. Also note that we can cancel x minus 1 from the top with x minus 1 from the bottom. And if we do so, this limit equals to limit of x minus 1 as x approaches 1. Now if we plug in 1 for x, this limit equals 0. So this example shows that it is possible that limit f over g exists. So this shows an example that the limit exists. And in this case, the limit is 0. But it is possible that the limit does not exist also. For example, consider this x minus 1 over x minus 1 squared. Again, if we cancel 1x minus 1 from the top and the bottom, we get to this expression, 1 over x minus 1 as x approaches 1. This limit does not exist because numerator is a non-zero number and the denominator gets closer and closer to 0. So this expression gets larger and larger. And so the limit does not exist. So this shows that this statement is not always true. So we say the statement is false, because always we cannot conclude from this and this that the limit of f over g does not exist. It is possible that it exists or does not exist. I hope you enjoyed this video and see you in the next videos.